How internet speed are categorized. This video is about all internet speed explained. Let's get started. Bits per second. Bits per second, BPS, is how we measure the speed of data moving from one place to another, like through the internet or a cable. Think of it like water flowing through a pipe. The more water that flows per second, the faster things move. Similarly, the more bits that travel per second, the faster your data transfers. A bit is the smallest unit of digital data, just a 0 or a 1. So bits per second simply counts how many of those zeros and ones move every second. In real life, you'll see it as megabits per second. Megabits per second when your internet provider advertises speeds like 100 megabits per second, meaning 100 million bits travel every second. The higher the number, the faster your videos load, files download, and calls connect. Kilobits per second. This is the smallest commonly used unit of internet speed, and it represents extremely slow data transfer by today's expectations. It was widely used during the early days of dial-up internet, when most online activity involved text-based websites, emails, and very small files. At such speeds, even loading a single image could take noticeable time. Today, kilobits per second speeds still appear in weak network conditions or simple connected devices like sensors. It matters because it shows the starting point of internet evolution, reminding us how dramatically speed and capability have improved over time. Next is megabits per second. This is the most familiar unit for modern users and forms the backbone of everyday internet plans. 1 megabit per second equals 1,000 kilobits per second, which allows for a significant improvement in performance. With speeds in this range, users can browse websites smoothly, stream videos in standard or high definition, and join video calls without frequent interruptions. As online platforms shifted toward media-rich content, megabits per second became the practical standard for households. It represents a balance between affordability and usability, making it the most commonly advertised speed by internet service providers around the world. Next is gigabits per second. Gigabits per second level of speed marks a major step into high-performance internet. 1 gigabit per second equals 1,000 megabits per second. When 5G was introduced, the internet speed reached from 1 gigabit per second to 20 gigabits per second, making things like Starlink internet, real-time cloud gaming, 8K streaming, remote computing, space data transfer actually possible. At this level, data is typically delivered through high-speed fiber optic connections. A practical example for 1 gigabit per second connection is like downloading a movie at speed of 125 megabits per second. It's like downloading a 10 gigabyte file in less than a minute. Next comes terabits per second. Terabits per second introduces a future-ready scale of internet capacity where 1 terabit per second equals 1,000 gigabits per second. To put it simply, at 1 terabit per second, you could download around 125,000 movies in a single second. Terabits per second is not your home Wi-Fi speed. It lives in the infrastructure layer, meaning the base layer of data transfer, like the invisible highways that connect cities, countries, and continents. Companies like Google, Meta, and Amazon rely on terabits per second links to move massive amounts of data between their global data centers instantly. Researchers have already demonstrated speeds exceeding 1,020 plus terabits per second on experimental fiber networks. Here's a real-world perspective. A 1 terabit per second connection could serve roughly 10,000 households simultaneously, all streaming 4K video at the same time without a hiccup. Next is petabits per second, kbps. If terabits per second sounds fast, meet its big brother, petabits per second, kbps. 1 petabit per second equals 1,000 terabits per second, or 1 quadrillion bits every single second. To wrap your head around that number, at 1 petabit per second, you could transfer the entire content of the internet as it existed in 2010 in just a few seconds. As of today, petabit per second exists almost entirely in research labs. In 2022, Japanese researchers at NICT demonstrated a transmission speed of 1.02 petabits per second over a single optical fiber cable, a world record at the time. Next is Ybps exabits per second. A speed so fast it feels like science fiction. Step even further into the future. Welcome to exabits per second, Ybps. 1 Ybps equals 1000 pbps. Does it even exist? The answer is not yet. No lab, no research paper, no experimental setup has come anywhere near demonstrating Ybps level transmission. The question is, what would Ybps actually enable? It is real-time planetary simulation, brain-computer interfaces at scale, interplanetary internet, full immersion digital reality. Ybps is not just a faster internet. It is the infrastructure for a version of civilization we can barely imagine today. Zettabytes per second. 1 zettabyte per second equals 1,000 exabits per second, or 1 sextillion bits per second. This speed is beyond an infrastructure. Not even all global internet traffic comes close. At this speed, we can copy all internet data ever created by human in less than a second. It reflects a future where the physical and digital worlds are deeply integrated and data flows continuously without noticeable delay. Yottabits per second, Ybps. Yottabits per second, Ybps, is the largest named unit of data transmission speed that exists in the official Ybps, is simply the last rung on the ladder that human mathematics has formally named for data speed. To understand ANSA 1 Ybps, you could theoretically transmit the information equivalent of every thought ever thought by every human who ever lived. Ybps matters not because we will ever use it, but because it reminds us that human curiosity always names the destination before building the road.